Hey everybody. In this video, I'm not really going to do any new instruction. I'm just going to go over a couple of exercises that appeared in the homework and on WebAssign. Ashley had some good questions, and I thought maybe in addition to showing the solutions to Ashley, I'd share them with everybody. So this is one of the exercises. And according to the directions, we use the graph of the function of f of x to determine the limit. So this is the graph y equals f of x. And they want us to look at the one-sided limits of f of x as x approaches c. And they tell us here that c equals -5. So what they really want here is x approaches c from the left. They want us to compute the limit as x approaches -5 from the left of f of x. Well, why didn't they just say limit as x approaches -5 from the left? It may have something to do with the way they designed the WebAssign program. Maybe it was just easier to frame the question in terms of x equals c, and then say c is equal to -5, or c equals -9, or c equals 2, or something, when they change the numbers around for each individual user. But what we want here is the limit as x approaches -5 from the left. That's what that negative sign indicates, from the left. So let's look at the graph of f of x. Here's -5. So x approaches 5 from the left if x approaches -5 from this direction. If x approaches -5 from this direction, then x is approaching -5 from the left. And if we move along the graph in this direction, then we're moving along the graph in such a way that x approaches 5 from the left. And if we move along the graph in such a way that x approaches 5 from the left, what value does f of x, the y value, get close to? As x approaches -5 from the left, doesn't f of x get close to 5? As we move along the graph in this direction, isn't the y value getting closer and closer to 5? So, as x approaches -5 from the left, f of x gets arbitrarily close to 5. This is our limit. The value that f of x gets close to as x approaches 5 from the left. Now they also ask this. One-sided limit as x approaches c from the right of f of x. Well, again, they tell us that c is equal to -5. So what we really want here is the limit as x approaches -5 from the right. That's what we really want. So let's go back and look at our graph. If x approaches -5 from the right, then x is approaching -5 from this direction. So if x moves in this direction, then x is approaching -5 from the right. And as we move along the graph in such a way that x approaches -5 from the right, what value does f of x, the y value, get close to? As we move along the graph in such a way that f of x, the y, let me try that again. As we move along the graph in such a way that x approaches -5 from the right, what value does f of x, the y value, get closer and closer to? Doesn't the y value get closer and closer to 5 as x approaches -5 from this direction also? See, the y value is getting closer and closer to 5. So this is also the limit as x approaches -5 from the right. Now they ask a third question. These WebAssign people, they're full of questions. They want to know the limit as x approaches c from either direction of f of x. And again, c is equal to 5. So what they're really saying is, what's the limit as x approaches -5 of f of x? Well, what do we know about, quote, the limit, end quote, as x approaches a number from either direction, and the two one-sided limits as x approaches that number from the left and from the right? Isn't it true that if the two one-sided limits are equal, which they are in this case, and let's note that, this is important, one-sided limits are equal. So that means the limit exists. And not only does the limit exist, but it's always going to have the same value as the common value of the one-sided limits. So what value does f of x approach as x goes to -5? It's the common value of the one-sided limits, 5. So the limit of f of x as x approaches -5 is 5. And then finally, there was another part to this. Is f of x continuous at x equals c? And the answer to this question is we don't know, because we haven't covered this in class. Okay, we don't know because I have not covered continuous functions in this class. So if you got this question wrong, this part of number 1 wrong on WebAssign, I will reimburse you the point. We're not responsible for this question because I have not covered continuous functions in this class. Now, there's another question that Ashley had, and it's a good question. So I'm going to put that back up on the board, and we're going to work that. Okay, next exercise. This has some similarities to the exercise that we did before, but it has some differences too. similar to the exercise we just did, it says that we want to use the graph to determine the limit. And here they tell us c equals 4. So what they want us to do here in part A, compute the limit as x approaches c from the left of f of x, but c is equal to 4. So they want us to compute the limit as x approaches 4 from the left of f of x. Now notice, if x moves in this direction, then x is approaching 4 from the left. See, if x is over here, then x is to the left of 4. And as x moves in this direction, x is approaching 4 from the left. Now, if I pick a point on the graph, and then I move along the graph in this direction, I'm moving along the graph in such a way that x approaches 4 from the left. And as I move along the graph in such a way that x approaches 4 from the left, what value does f of x, the y value, get close to? Well, I'm looking at this line, this part of the graph, and it looks like the y-coordinate of every single point on this part of the graph is 2. The y-coordinate of this point is 2, the y-coordinate of this point is 2, the y-coordinate of this point is 2, the y-coordinate of this point is 2. So as I move along the graph in such a way that x approaches 4 from the left, the y value remains constant. The y value remains constant at y equal 2. So what value do you think the graph is becoming arbitrarily close to as x approaches 4 from the left? Well, the y value of the graph is staying right at 2. So the only value that the y value of the function can be getting arbitrarily close to is y equal 2. Now there's another way that we could look at this. No, it says use the graph to determine the limit. So no, I think we're going to do this. We're going to do it exactly the way that we did it. As we move along the graph in such a way that x approaches 4 from the left, the y value of the graph remains at 2. So the y value of the graph, f of x, is getting arbitrarily close to 2. Now we'll do the same thing as we move along the graph in such a way that x approaches 4 from the right. That's the second question that they ask. Limit as x approaches c from the right of f of x, and they say that c is equal to 4. So limit as x approaches 4 from the right. I hope I said right before. X approaches 4 from the right. Okay. If x is over here, then x is to the right of 4. And if x approaches 4 from this direction, then x is approaching 4 from the right. And if we move along the graph in such a way that x approaches 4 from the right, what value does f of x, the y value, get arbitrarily close to? Well, as x approaches 4 from the right, isn't the y value of f of x staying right at y equal -2? So as x approaches 4 from the right, the y value is getting arbitrarily close to the only value that it assumes here, which is -2. At this point, y 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 is -2. As we move along the graph in such a way that x approaches 4 from the right, the only value that f of x, the y value, is getting arbitrarily close to is 2. So that's our limit as x approaches 4 from the right. Now there are two more parts to this exercise. C, they ask us to compute the limit as x approaches c of f of x. The limit as x approaches c, quote, the limit, end quote, as x approaches c from either direction. See, they don't just restrict it to approaching from the left or approaching from the right. Here, there's no plus or minus superscript to the right of c. So this means they want, quote, the limit, end quote, as x approaches c from either direction. And what do we know about, quote, the limit, end quote, and the two one-sided limits? Well, let's see. I guess the first thing we need to do is make sure that we've done the problem correctly, which I haven't. And if you were getting concerned, you had every right to be. Didn't we establish that as x approaches 4 from the right, the y value gets arbitrarily close to it's -2, isn't it? So -2 is the one-sided limit as x approaches 4 from the right. And in case I had been misstating that all along, let me just go over it again. As x approaches 4 from the right, x is approaching 4 from this direction. And as we move along the graph in such a way that x is approaching 4 from the right, the y value is constantly -2. The y value here is -2, the y value here is -2, the y value here is -2. So as x approaches 4 from the right and we move along the graph in such a way that x approaches 4 from the right, f of x, the y value, gets arbitrarily close to the only value that it's assumed, which is -2. So the limit as x approaches 4 from the right is -2. And I apologize if you were getting very apprehensive because of what I said before. Okay, here are the two one-sided limits. Part C, we want, quote, the limit, end quote, as x approaches 2 from either direction. Now, what do we know about the two one-sided limits and, quote, the limit, where x can approach from either direction? Isn't it true that if the two one-sided limits are equal, then the limit of f of x exists? But the two one-sided limits aren't equal here, so what does that tell us? One-sided limits not equal the limit does not exist. The two one-sided limits are not equal, so this thing that we call, quote, the limit, end quote, does not exist. So here's our answer. If the limit doesn't exist, we type in capital D, capital N, capital E. No spaces in between. DNE for does not exist. And that's our answer. And then there's a fourth part to this question. Is f of x at x equals c or x equals 4? Again, the answer is we don't know, because I have not covered continuous functions yet. So just like in the first exercise that we did, if we got zapped a point for getting this part of the exercise incorrect, I will reimburse you on WebAssign. We can't answer this because I haven't covered the topic in class yet, and there's no reason in the world why we should know the answer to this part of the question. Now, the rest of the exercises in this WebAssign assignment have nothing to do with continuity. So go ahead, proceed boldly forward. And the next lecture video that I send out is going to be an introduction to, oh, you'll never guess this, an introduction to continuity and continuous functions. These are good exercises. I'm glad that Ashley asked about them. No doubt some of us had been wondering about these exercises too. So if you have questions on homework, especially questions on exercises that are from the textbook, by all means ask me about them. If you can, please send me a snapshot of them. I'm without a text right now. But just send me a snapshot of the text and tell me what page and number it is. And if I don't get too many of them, then I'll be glad to honor all requests. If I get a bunch of questions, I'll try to do as many as I can. And I will try to do as much of a variety of questions, just so that we all know what we need to know. So if you have any questions on homework, especially homework from the text, please just do what Ashley did. Send me a snapshot and ask about that question. And I will try to get around to answering all of the exercises, okay?